Welcome to ClickMyProject.com. Let me discuss about the process Wavelet based approach to signal activity detection and phase picking. Application to acoustic emission. Let me discuss about the abstract of the project. Perform acoustic signal detection and improved phase picking of transient wave arrivals of a low amplitude. Here wavelet transform based algorithm proposed, which is based on the wavelet theory. The proposed method perform phase picking efficiently. Even the signals with a very low signal to noise ratio. Initially optimize the block size based on the rise time. Then proposed block thresholding scheme with adapted block length. Estimate the probability of signal presence and time of arrival based on POP analysis. These techniques are shown to provide high signal to noise ratio, good signal discriminant from very close echoes, and accurate detection of signal arrival time. The proposed methodology has been tested on real data collected in environments and where its benefits can be shown. Acoustic signal detection has become an object of interest due to its utility and applicability in fields such as particle detection, underwater communication, and medical issues. The probability that a given coefficient contains a significant noise component, all the probabilities are estimated assuming a generalized Laplacian prior for noise-free subband data and additive white Gaussian noise. Time of arrival is the travel time of a radio signal from a single transmitter to a remote signal receiver. Time of arrival uses the absolute time of arrival at a certain base station rather than the measured time difference between departing from one and arriving at other station. The distance can be directly calculated from the time of arrival as signals travel with a known velocity. Let me discuss about the flow diagram for our process. Initially, the input AE signals are generated. Acoustic signals are noises that animals produce and response to a specific stimulus or situation that have a specific meaning. Several features combine to create a meaningful auditory signal. The first of these is the frequency or pitch of a sound. Another variable is the amplitude or loudness. Different combination of these two features can drastically alter the meaning of a sound. The circumstances that surround acoustic signals can also alter their meaning. These include the time of year and time of day, spatial location, weather conditions, and physiological state of the organism. Next, the addition of AWGN noise with various dB. Various dB noise are added into our input AE signal. Next, estimation of rise time for under damped system. Rise time is the time taken by a signal to change from a specified low value to a specified high value. Rise time is an analog parameter of fundamental importance in high-speed electronics, since it is a measure of the ability of a circuit to respond to fast input signals. Many efforts over the years have been made to reduce the rise times of generators, analog and digital circuits. Measuring the data transmission equipment focused on the research of faster electron devices. Next, determine the neighboring block. So determine the block length and the probability of presence has been estimated. Neighboring block method is a contrary. It is applied in a group of successive coefficients and the threshold is calculated within adjacent blocks of coefficients. The method resembles a sliding window that calculates a threshold value within a neighborhood and applies this threshold in a central block of this neighborhood coefficients. The estimation of probability of presence. Signal presence probability from the estimation of clean speech spectral coefficients in a signal enhancement task using both a fixed a priori signal to noise ratio and a fixed priori probability of speech presence. The proposed posterior signal presence probability estimator achieves probabilities close to 0 for signal absence and probabilities close to 1 for signal presence. Then the time of arrival. TOA estimation requires enhancing the time domain resolution of the channel response in order to resolve the paths and enhance the accuracy of estimation. Compared to the TDOA technique, time of arrival uses the absolute time of arrival at a certain base station rather than the measured time in difference between departing from one and arriving at the other station. The distance can be directly calculated from the time of arrival as signals travels with a known velocity. Time of arrival data from two base stations will narrow the positions to a position circle. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right-click that file and run for executing this process. Here we estimated the activity detection for our acoustic emission signal. Here we have to select any one acoustic emission signal from the dataset folder, and from that signal we have to analyze the activity detection of our input signal. Here the noise will added into our input signal, and based on the wavelet based algorithm and also block based threshold method, we analyze the activity of the input signal. After execution of the entire process, we can compare the wavelet based and block based thresholding algorithm for our input signal. After execution of this process, we compare the result. This process will take some time for executing. Once the completion of the process, this is the reference acoustic emission signal, and this is the noise acoustic wave when the noise ranges is 10 dB, and this is the 5 dB noise range, and this is the 0 dB noise values. This is the minus 5 dB noise values, and this is the minus 10 dB noise range. The noise range is the minus 20 dB. This is the noise audio wave, final noise audio wave. This is the AE activity, acoustic emission activity. Red color lines represents the wavelet based picker, and black color lines represents the threshold based picker, and this is the AE activity difference. This is the reference AE signal. This is the final noise acoustic wave for our, in this line, this blue color line represents the time of arrival estimation. This denotes the time where we obtain the maximum value, and this is the time of arrival. In this time we obtain the maximum value for our minus 20 dB signal. Finally, we analyze the block thresholding approach and also wavelet based approach. This is for wavelet based result, and this is for block based results for our minus 20 dB noise range time of arrival result. Thank you.